Okay, welcome back to COSC 2325. In this video, we're just going to be coding. So we're going to look at the different things that we've learned in this chapter, and I just want to show you some common mistakes as you start coding in assembly. This template that you see here is with this video on Canvas, so you can just pull it up and just start coding where I start. So the first thing that I wanted to go over, I'll go over everything, is the following. So let's say that I were to create a variable in this section, in the data section. So let's say that I call the variable var1, and I define this variable size word. So word is 16 bits, and I assign it the constant literal 5. So var1 is 16 bits and holds a 5. And now let's say that I say move into EBX var1. So let's see what happens. So I'm trying to move that 5 into EBX. So it says there was a build error. Would you like to continue and run the last successful build? I don't want to build the last one. So I'm going to stop. And I don't know if you can see here, but if you run it yourself, it says instruction operands must be the same size. So right here, move EBX. EBX is 32-bit register. var1 is 16-bit. So they're not the same size. So we can't move the 16-bit. We can assign 16 bits to 32 bits. It does not allow us to do that. So there's two things you can do. You can change word to 32 bits by using dword. So double word is 32 bits. And it's happy. So that works. The other thing you can do is you can just use the 16-bit version of EBX, which is just BX. So remember, EBX gives you the whole 32 bits. BX, this is back from, I think, chapter 2, gives you half. So it gives you 16. So now it's 16 and 16, so it's also happy. Okay, so I'm gonna go back and put this a double, and so the next thing I want to show you is we've looked at the registers and we've looked at what values in the registers. Well, many times you want to see what values are in your variables. So to be able to do that, you want to set a breakpoint wherever it is that you want your breakpoint. And so let's say that, so at this point, I want to see what's in var1, my variable 1. I'm just going to set a breakpoint here, and I'm going to run my code, the program. And the last program I was doing had a variable called sum, and now it thinks that I still have that variable. And so I said, I remember now. So before I was doing the watch window for sum, and well, now there's not a sum identified. So I'm just going to go ahead and delete this because it's old. So I can delete watch or clear all. So A1, delete that. Okay, so now I want to go ahead and take this var1. I'm going to highlight it, and I'm just going to move it to here. And now I'm going to watch. I get to watch what happens to var1. And var1 currently has a value of 5, and nothing else is going to happen to var1 because we're not doing anything else to it. But I can watch, if I was doing other things to var1, I could watch that there. So I can debug, step into it or over it, and var1 still a 5. Okay, I'm in debug, so I can also go to debug windows and look at my registers. So now I have, I want to look at both windows. So I'm going to move my registers over here to my right. Oops, smaller. Okay, maybe I'll just move it over here. Let's see all my registers. Smaller. So I have those there, and then I want to do the quick watch. So there's my quick watch one. Well, no, not that one. Task. My watch window. Yeah. Okay. So there's my watch window, there's my registers down here. So at this point, I can look at EBX, and EBX has 5. So that's what's happening with my variable, that's what's happening with my registers. Okay, I'm gonna go ahead and just let this finish and continue. The next thing I wanna do is I wanna define, I want to use subtract and add. So let's say, for example, I wanted to add A plus B. So I have a variable called A, and I have a variable called B, and maybe this has a 1 in it, and I want to add those two together. So assembly language does not allow me to just say sum A comma B. If I try to do this and try to add two variables, it gives me an error. And so just a syntax error sum. And let's see, what else does it say? That's all. So what I'm going to have to do then is I'm going to have to take, I have to make a register, and I need to put something into a register, either A or B. So I can move into, let's say, register EAX. I can move A into there, and then I can add EAX and B. So move A into EAX and then add B and EAX. Remember that what you can do in a high-level language in one statement is going to take you sometimes 2, 3, or 4 statements with assembly language. So it's just the way it is. Okay, so at this point, I want to go ahead and set a breakpoint and run it. And I see that A So here's EAX, it has some random value that was assigned to it. I'm going to step over that, and now EAX has a 5. So 5 was moved into EAX, and now I'm going to debug and step over, and then now EAX is 6. So it added the 5 and the 1 together. The 5 and 1 are added. Also, we can look at our watch window, which we don't have A and B, but we could put A and B here. So I'm going to delete this one, and I'm going to copy A and add it to there, and I can copy B and add it to here, and I can also watch those if for some reason later on I change them. Okay, so I've added, and with add, I can, remember I can do either, so this is the source, this is EAX, this is the one that's changing, but let's see what happens if I do this. So here, I've swapped. B is my source, EA is my destination, sorry, and EAX is my source. So let's see, let's watch A and B. Oh, we have to stop debugging first. Let's run it. So A is 5, B is 1. We're going to move A into EAX. So looking at our register, EAX now has a 5. Let's look at our watch. So now we're going to move EAX to, we're going to add EAX and B. Debug, step over. But when you add EAX to B, which is 6, your destination is B. So it puts that 6 in B. So it's changing B, not changing EAX. If that's what you want to do, then there you go, you can do that. Same thing with subtract. So we have add and subtract. And so let's say that we put A into EAX, then let me stop this debugging again. So then we say, let's subtract, let's take 1 away from 5. So 5 is in EAX and 1 is in B. So we're taking 1 away from EAX. EAX is 5. So here EAX should then now hold 4. So debug, step over, and then let's see what let's go ahead and stop. Let me just run this first. Okay, so run's okay. I'm going to go ahead and put my break and run it. Okay, so A has 5, B has 1. There's EAX. So now EAX has a 5 because A is 5. And now EAX is 4. So we took 1 away from 5 and we assigned it to EAX. Okay. Stop. So let's add, subtract. We want to make sure that our registers are match the size of whatever variable or constant we're assigning. So for example, like if I make this a byte, and the biggest value in a unsigned byte is 255. So if we just put like a large number and we run this. So, well, first of all, it's not going to let us do this right here. So let's just take this out. And we're just going to run it. Okay, so initializer magnitude too large for specified size. So it's saying it's too big to initialize A. A cannot be bigger than a byte, which holds 255. Yeah, initializer magnitude too large. Okay, let's try 255. That one, it's okay, because that's the largest value that we can put into 1 byte. 0 to 255 is an unsigned byte. So you can hold a person's age, you can hold, if you have a menu that the options are 1, 2, 3, 4, 5, then that is just enough. So remember when we're creating our variables here, or we're creating a maybe a constant, that we always need to initialize our values. Or if I use a question mark, then I'm just saying, hey, I don't want to initialize it. But if I just leave it blank, then it gives me an error. So leaving it blank is not an option, but you can put a question mark. A question mark will not initialize the value of A. So let's just run it and let's see what's in A. Let's put a breakpoint here, run, and then look at our watch window. And A contains a null value, so it doesn't contain anything. And B has a 1. Now let's look and see how we create symbolic constants. So a symbolic constant would look like this. I'm going to delete this right here. And let's say, for example, so the, I think over this symbol. Okay, so let's say that we have a program and we're looking at, I don't know, the months of the year. Okay, and so I want January to have symbol 1 because it's the first month of the year. So my symbolic constant, I can call it anything I want. So I'm going to call mine Jan for January. And then I'm going to assign it the number 1, so January. So that's called a symbolic constant. And then I can use Jan from now on. Instead of using a 1, I can use Jan. And I can do things like, is it January? Or I can, add 1, I can increment January to 2, and now I know I'm at February, or I don't know, whatever you want to do with it. But this is how we can define our symbolic constants. So I could do February equals 2. So it's just an assignment statement. I don't have to tell it how many, it's not grabbing a memory location for this. I don't just tell it like, is it 2 bytes or is it 4 bytes or anything like that. So the other thing I can do also is I can define a symbolic name. So in the last lecture, I showed you how what characters you need, what sequence of characters you need to say, give me a new line. And I'll showed you how we could create a symbolic name for that. So from then on, you don't have to use those specific numbers and letters. You can just use new line or whatever you decided to call that escape sequence. So we can do the same thing. Oh, and I do have this in the wrong section because this is our data section. So this would actually be, sorry about that. I'm on a Mac working on Windows, so I'm having to, I'm usually, I'm trying to do shortcut keys, and I'm always doing command instead of control. Okay, so control V. This goes really slow. So my symbols are going to be up here. So when I define my symbols, my symbolic constants, and then my data is going to, my variables are going to be here. So another symbolic constant can be symbol 1. And this time I'm going to use the text, text EQU. So when I use text EQU, it says that I can create a symbolic name that is a string. And my string is going to be in the greater than less than sign. And then inside, I'm going to put whatever string I want to put in there. So it could be something like system failure, or press any key to continue. And then maybe this is something more descriptive, like SF for system failure, and return like that. So this is how we create our symbolic constants, and this is how we create our symbolic names. So from then on, you don't have to type this every time that you're just pressing the key to continue or system failure. You don't have to type all these. So we use these typically for shortcuts and to make the code more readable. So from then on, you can use return, or better yet, use return, or you could use R if you wanted, any of those options. Now, this is just a symbolic constant. Then here, let's say that we wanted to create a actual an actual variable to use this. So let's say that the variable is called return RTR, and RTR would be defined as a byte, and it would be R. So we have RTR byte R. So this would be our actual variable, RTR. So from then on, we can use RTR in our program. Same thing for our days, for our, not days, but for our months of the year. If we wanted, we could create an array of months, which is like an assignment that you have where you create an array of days. So you could do months, right, and then you would have January, February, comma. As you create these, you could list them all. And now you have an array of the symbols that represent each month. So it'd be an array with a 1, a 2, a 3, a 4, etc. Okay. And that will not work. That is in C++. Okay. So I think that is all that we've covered so far. So that's just a review of everything. And then, of course, we talked about duplicating and initializing um, more than one variable, more than one memory location at one time. So that would also be done here. So if you wanted, you could say like var1, and let's say that it's a word size word, and you want 10 of them, and you want to put inside this, you want to put the letters A, just the letter A. So then this would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 A's. We're duplicating, we're initializing 10 memory locations. Each memory location is 16 bits because a word is 16 bits. So 16 bits, that's a word, times 10, this is 10 of them, would be 160 bits. 8 bits, sorry, 8 bits is 1 byte. So I just think if a word is 16 bits, then this is 2 bytes, right? So 2 bytes times 10 is 20 bytes. So if you divide 160 divided by, if you in your calculator, you put 160 divided by 8 equals 20, because 8 is 1 byte. Okay, and I keep repeating that just because I know it could be confusing at first. All right, I think that's all that I have for this. And this will definitely get you to be able to complete your Chapter 3 lab assignment. Okay, good luck, and it should not be too terrible. But email me if you have any questions.